So in class today, I worked this one a little. I got the right answer, but I actually skipped a step, and I want to show you what I did. First, I didn't write my limit notation right then, so let me fix that. I'm separating this into two different limits. So in class, what I forgot to do, and what I'm actually doing right now, you're going to have to watch me. I'm not always the best at details. But what I forgot to do in class today is I forgot to write the sign of 3x. So let's go back and rework the problem. I forgot to write the sign of 3x right there. Okay, so right here I'm going to use my theorem. That becomes 1. And then the cosine of, well, 3 times 0 is 0, so the cosine of 0 is 1, so I get 1 as my limit right there, okay? Well, I could use the theorem with cosine and say 3x over the cosine of 3x is 1, but then I would still have to deal with cosine of 3x over the sine of 3x. And the sine of 3x would give me 0, and I don't want that. So what I'm going to do is I'm going to use the theorem right here. And so the sine of 3x over 3x is 1. And basically, what you're dealing with is the limit of 1 times cosine of 3x over the cosine of 3x. First of all, the cosine of 3x over the cosine of 3x completely cancel and give you 1. Or you could think of it as cosine of 3 times 0, so the cosine of 0 is 1, divided by the cosine of 3 times 0, and the cosine of 0 is 1. So it's 1 over 1, which is still 1. Anyway, moral of the story, that limit came out to be 1. And your answer is still 2. So I'm going to work a couple examples that I didn't get to today in class. And you're going to have something like this on your test. And there's going to be a little template that you'll fill out and things like that. But let's look at the first thing it asks us to do is find the vertical asymptote. Set the denominator equal to 0. So x minus 2 equals 0. I get x equals 2 is my vertical asymptote. So for the horizontal asymptote, remember your shortcuts. With this particular function, it's top heavy. So we're dealing with this option right here. And when you're top heavy, you have no horizontal asymptote. Okay, since there is no horizontal asymptote, we might have a oblique or a slant asymptote. That slant asymptote happens when you have your numerator has a degree of exactly 1 more than your denominator. So, and this is the case that we have. So I'm going to use long division right here. So 2x squared. There's not a power. There's not an x to the first power right there. So I'm going to put a placeholder of 0x plus 5, and I'm going to divide that by x minus 2. So what do I have to multiply x by to make it be 2x squared? I have to multiply it by 2x. So 2x times x is 2x squared. I then have to distribute 2x to the negative 2, and I get negative 2x. I want to find the difference of that, so I get, since it's now the 2x squared minus the 2x goes away. If it doesn't, you did something wrong. And then I say 0 minus a negative 2x. So I end up with a positive 2x right there. I'm going to bring the 5 down. So I'm saying what can I multiply x by to give me 2x? And you could multiply it by 2. or, yeah. And look, y'all, I found a mistake. Been bad at making these today. When I said 2x right here, and I multiplied it by x, I got 2x squared, that's correct. But when I said 2x times 2, y'all, that's not 2, that's 4. So let's go back and redo some things right there. I'm so sorry. So 0 minus a negative 4 is a positive 4x. So now what I'm saying is, what can I multiply x by to get 4x? And you can multiply it by 4. Okay. So 4 times x is 4x. Let's try to do this right. 4 times negative 2 is negative 8, and you're subtracting, and you come up with 5 plus 8, essentially, and that's 13, a remainder of 13. But your oblique or your slant asymptote does not care about the remainder, so it is just y equals 2x plus 4. Now, x-intercepts. X and y intercepts, you basically do an xy chart and plug in 0 for x and 0 for y. When you plug in 0 for x, that'll give you your y-intercept. And I'm not labeling that the value of y, I'm saying y-intercept. So let's just make that different a little bit. Well, this is your y-intercept, and this is your x-intercept. Okay, so let's plug those values into the function and see what we get. The function of, let's see, gotta find it, 2x squared plus 5 over x minus 2. Sorry, y'all, I'm trying to zoom it in. If you plug 0 in for x, you come up with negative 5 halves. And so that's when you plug 0 in for x. When you plug 0 in for y, you're just saying 0 equals 2x squared plus 5 over x minus 2. And what you can do here is some cross multiplication, and you end up with just 0 equals, because 0 times x minus 2 is 0, and you're saying 1 times 2x squared plus 5. So 0 equals 2x squared plus 5. And you do this, and let's see, you can say 2x squared equals negative 5, and you could divide by 2 and get x squared equals negative 5 halves. But you go to take the square root, and it's imaginary. So there's not a y-intercept. So right here, not y-intercept, because we can't do imaginary numbers there. Okay. So is there symmetry? Well, if f of x, let's see, if f of x equals 2x squared plus 5 over x minus 2, f of negative x would be 2 times negative x squared plus 5 over negative x minus 2, which the numerator looks good, but that denominator is just not the same as the original. So it's not even, meaning there's no y-axis symmetry. Okay, well, let's see what negative f of x is. That would just be putting a negative in front of your f of x. And if I simplify that out, it's not going to equal what f of negative x equaled. So since f of negative x and negative f of x are not equal, it's not odd, meaning there's no symmetry about the origin. So let's take some things that we know and come up with a graph. Actually, is that the graph right there? Let's see. There is a x-intercept. I didn't realize we had a graph to look at. There's an x-intercept at 2. Yep, that's right. And the y-intercept, there's an vertical asymptote at 2. The x-intercept was at negative 5/2, so let's see if that's right. Looks about right to me. 5/2 would be 2.5. And the oblique asymptote, the slant asymptote, would be the line y equals 2x plus 4. That's not the line y equals 2x plus 4. That slant asymptote isn't. So what this is, it was just showing you an example of what a slant asymptote looks like. That's not the actual graph. So your actual graph, let's see. Let's draw one out. And look, this is going to be a little scratch, so bear with me. I meant to change that to black, okay? There is a vertical asymptote at x equals 2. There is a slant or oblique asymptote at 2x plus 4. So I would go to 4 on the y-axis, plot a point, and use my slope for the next point. So the slope is 2, so you rise 2 and run 1. So that is your slant asymptote. I know I have an x-intercept at negative 5/2. And negative 5/2 would be 2.5, negative 2.5. So there's an x-intercept for that graph right there. So what I'm doing from here, since I plotted my x-intercept and my asymptotes, I'm just doing a table, an XY table, and it doesn't look like I plugged in 3, right? So it doesn't look like I'm going to have enough room to plot the point 23, the y value of 23. So this whole area of the graph is going to be pretty much blank. However, I'll plot these. And if I plot 1, 3, let's see, 1, 3 is about right there. And if I plot negative 2, let's just do negative 1 first. Negative 1 and negative 7/3 would be about right here. No, that's not 2. About right here. Negative 13/4. Well, 12/4 is negative 3. So negative 13/4 would be just a tad bit lower. So this is going to look kind of wonky because I graphed it, well, I know why it's looking kind of wonky. This point right here, I did 1, 3, and that's incorrect. It's actually supposed to be 1, -7. Which would put that guy, let's see, 1, 2, 3, 4, 5, 6, 7, which would put it right here. And all of a sudden, that graph looks a lot better and is following those asymptotes. So this one we're looking at says to graph the two functions and compare. The first thing I'm going to find is the vertical asymptotes. And it looks like they're going to be the same for both functions. I get x equals plus or minus 1 for the vertical asymptotes. And that's, again, by setting the denominator equal to 0. So when you set x squared minus 1 equals to 0, you get x squared equals 1, and you have to take the square root of x squared and the square root of 1 to get plus or minus 1. Okay, so from here, horizontal asymptote, the degree of the denominator is different. Is than the degree of the numerator. It's bottom heavy. So we have a horizontal asymptote of y equals 0. And even though the function to the right is different, it's still bottom heavy. So it has a horizontal asymptote of y equals 0 as well. Now, since they have a horizontal asymptote, there's no oblique asymptote or no slant asymptote. I did go ahead and plot my asymptotes on those two graphs above. From here, I want to do x-intercepts and y-intercepts. I'm just going to plug in 0 for x and 0 for y. Okay, and so if I plug in 0 for x into the function on the left, I get 0 squared, and then I get just 1 over -1, so that's going to be -1. And when I plug in 0 for x on the right side, I get 0, because 0 divided by 0 squared minus 1, that's 0 divided by -1, so that's 0. Which tells me that if you plug 0 in for y, you get 0 as well. Okay, so that's both the x and the y-intercept since it crosses at the origin. For the function on the left, let's plug in 0 for y. So if I plug in 0 for y, that would be saying 0 equals 1 over x squared minus 1. And that's cross multiplication. So I get 0 equals 1, and 0 does not equal 1. So there's no, that would end up being an x-intercept. There's no x-intercept. So you know what? Let's plot those points. Let's see. And I'll do the graph in red, I guess. So we cross through 0, -1. And that's our y-intercept. And here we cross through 0, 0. Okay, to keep going, we just need more points. So let's do an XY chart. So I went ahead and just chose some x values and found the y values, and I went ahead and graphed it out for us. And what's important when choosing these x values, you can really choose anything you want. And again, y'all, I'm having trouble zooming. There we go. But you want to make sure when you're choosing those x values that you choose at least 2 points on each section broken up by the vertical asymptotes. So so you have this left section and this middle section and this right section. And then that's the same thing that I tried to do when we came over here. We still had 3 sections, and I chose x values in each section broken up by the vertical asymptotes. Now on that second graph, you can see where we actually cross the horizontal asymptote. And that's perfectly fine because you can, if you'll remember when we went over horizontal and vertical asymptotes, you can cross a horizontal asymptote. You just can't cross a vertical asymptote.